Hi everyone, this is question number 17 in circular measure. We need to find the area of the segment. The formula involved to find the area of segment is we shall take the area of the sector and minus the area of the triangle inscribed in that sector. And the formula of the area of the sector is half r squared theta. The area of the triangle inscribed, we shall use the formula learned in solution of triangle, half AB sine C, just that the A and the B happen to be the R, so half R squared sine theta. And the theta here must be in degree. So we can factorize this, half R squared theta minus sine theta. So we're going to use this formula to solve all the questions involve this segment. So for part A, area of the segment is half, the R is 5 squared, the theta is 1.2 radian, so we minus sine, we got to change the 1.2 radian into degrees, so 1.2 times degree over the pi at the bottom. Okay, then we just use the calculator and do the calculation for us. So half times 5 squared, which is 25. Okay, and then times, using bracket, 1.2. And then minus sine, bracket, 1.2 times 180 divided by the pi value in the calculator, since there is no pi given in the question. Okay, so equals to 3.349, but to round it off, we have to round up to 3.35. So the answer is 3.35 cm squared. And for part B, the area of segment is over here, but the angle given is not the angle for that sector. So we have to find the angle for that sector. So angle ROQ will be 180 minus pi over 4. So 180 is actually pi. So pi minus pi over 4, we will have 3 pi over 4. So that is the angle that we need to use, 3 pi over 4. Therefore, the area of the segment will be half 11 squared. And then take the theta, which is 3 pi over 4 minus sine. The 3 pi over 4, so we can convert to degree by multiplying 180 degree and pi at the bottom. Okay, so use the calculator and do the calculation. So 2 half 1/2 times 11 squared, and then times with 3 pi over 4. So 3 pi over 4 minus sine. Okay, 3 pi over 4 times with 180 over pi. Close bracket. So the answer is 99.769. So we need to round off to 4 significant figure. We will have 99.77. 99.77 cm squared. So we found the answer for B. Next, go to C. Now in C, the segment, all right, we have to use the sector. So let's create the line so that we can see very clearly there is a sector there. Let me just use the highlighter. This is a sector that we're talking about. So we use the area of this sector minus the area of the triangle inscribed in the sector. Now, but we don't have the angle here, so how do we find? So do you see the quadrilateral, cyclic quadrilateral. Yeah, the cyclic quadrilateral, we shall use that to find the angle. Okay, or we can use the angle at the circumference and angle at the center. Both can give us the answer. So if this is 120, the angle opposite will be 60. So if this is 60, this is 60, and definitely we know that this is 60. 60 degree basically is pi over 3. 180 divided by 3, isn't it? Therefore, if this is pi over 3, therefore the angle here will be pi minus pi over 3. So let's find that angle first. Angle AOB is pi minus pi over 3. We will get 2 pi over 3. So with that, area of the segment, we shall take half r squared. The r is 8, so 8 squared. Theta, 2 pi over 3 minus sine 120 degree. Okay, that is 120 degree for sure. This is 60, so this side is 120. Okay, or you replace the 180 here. So 2 times 180, 360 divided by 3, you got 120. So with the help of calculator, half times 8 squared, and then times 2 pi over 3, and then minus sine 120. Close bracket. So the answer is 39.31. So we have 39.31 cm squared. So that's it for question number 17.